Hello, algebra students. Mr. Lawrence here, and this is kind of a reverse flip lesson because we talked about this stuff in class on Wednesday, and this video you should be watching Thursday night, I think, because of the park on Thursday. Anyway, so let's just get down to it. All right, sorry, confusing myself here. All right, first of all, let's see how you can do with a little mini quiz here. There's 3 problems there, and I want to see if you can tell me what x equals. Okay, go ahead and take a moment and put down what you think the answers are. Okay, so here come the answers to the quiz. You can grade yourself. Okay, this one here, there's 2 possible answers because remember the definition of absolute value is the distance from 0 on a number line. There are 2 numbers that are 6 units away from 0 on a number line. How did I know 0? Whatever makes that 0 is what I'm looking for. So normally you don't have to do a whole number line here, but if I add 0 and I want to move 6 this way, I end up at positive 6, but if I go 6 units the other way, I end up at negative 6, right? Okay, so there's going to be 2 answers. Now, the long way of getting the 2 answers, which in some problems is the only way to do it, is to go, well, take 2 problems, x equals 6 or x equals negative 6, and then solve for x. Now, in this case, there really is no solving because x is alone. Some of you go, Mr. Lawrence, I just know. Absolutely you do, but we have to talk about it because the problems you're going to do down at the bottom, you're going to have to do in 2 pieces. You can't just get the positive and then change the negative. It doesn't work that way. Did you hear that, Sean? You can't just do it. There's no shortcut. Okay. Problem 2 here, absolute value of x equals 0. I'm asking you what number or numbers are 0 units away from 0. Well, there'd only be one. X would equal 0, and that's the only solution, right? There is no negative 0, so I can't write it as two equations. This one here, I'm asking you what numbers are negative 2 units away from 0, and that should bother you because distances can never be negative. This problem has no solution. Because if you tested it, if you thought, oh, there's going to be x equals 2 or x equals negative 2, just like the first one, 6 and negative 6, then test it. Put 2 in for x. Absolute value of 2 does not equal negative 2. That doesn't work. Absolute value of negative 2 is 2, which is not negative 2. Doesn't work. There is no solution. Okay. So check out problem number 1 here. Problem number 1 is really important, okay? Laura already knows this. She came in for help on Monday. But this is really important. You cannot just solve it one time. A lot of you are going to go, hey, I'm going to add 4. This is illegal. You cannot do this in mathematics. You cannot do operations through an absolute value, okay? What you need to do is, remember, there's going to be 2 answers in many cases, right? You need 2 equations. The first equation is easy. 2x minus 4 equals 10. Okay, you got that? See, there's no absolute value bars in it. Catch this, James? Or, now I write down 2x minus 4, and that's going to equal negative 10. Okay, let's add 4 to both sides. I'm solving for x now. So I'll get 2x equals 14. Divide by 2. X will equal 7. Now pay attention to this because many of you are going to go like this. You're going to go x equals 7 or x equals negative 7. Cool, I'm done. And then you're going to argue with me about how it's not right. We're not going to get negative 7 or, oh, we are going to get negative 7. Oh, make a liar out of me. We are going to get negative 7. No, we're not. Sorry, I'm outthinking myself. Let's solve it and find out what we get. We're not going to get negative 7. Okay, 2x equals negative 6. Divide by 2, divide by 2, x equals negative 3. There we go. We did not get negative 7. We got 7 and negative 3. So you see, the way to solve these is to write them as two problems. You write what's inside the absolute value and then equals the 10, or what's inside the absolute value equals negative 10. One is helping us find the number that is on the positive side of 0 of the center, and this one on the other side of the center. Okay? All right. So number 2 here is an and. It's not an or problem, it's an and. How do I know that? Because of less than. Remember that from earlier in the year? I need to write 2 equations. Got that? 2 equations. Colton, we need 2 equations. Oops, there's no equals there. Sorry about that. Okay. So, and 3x plus 6 is greater than negative 18. Yeah, I have to flip the inequality when I change that sign. All right. Going to subtract 6 and get 3x is less than 12. Divide by 3, divide by 3. X is less than 4. All right, going to subtract 6 and get 3x is greater than negative 24. Divide by 3, divide by 3. X is going to be greater than negative 8. I forgot my and. I need my and. Here's my solution. Now, what would that look like on a number line? Well, let's see here. I have to show negative 8. I have to show positive 4. Okay? Will my points be open points or closed? You should know this by now. You should have known this coming into me. They're open points because they're not equal to. Yeah, I didn't say the word equal. Remember, I accidentally put the equal in and I had to erase it. It would have changed my answer. Now, where are all the numbers that are less than 4 and greater than negative 8? Well, they're all right here. And that's what your graph looks like. Okay, number 3. Can you see it there? Number 3. Similar situation. I need 2 equations, or inequalities. 4x minus 1 is greater than or equal to 20. And this is a great or. So, oops, I almost wrote the greater symbol. Or 4x minus 1 is less than or equal to negative 20. Yeah. Okay, gonna solve. So add 1 to both sides. We have 4x greater than or equal to 21. Divide by 4, divide by 4. X is greater than or equal to 5 and a fourth. Or add 1, 4x is going to be less than or equal to negative 19. Divide by 4, divide by 4. X is going to be less than or equal to negative, where am I, 3 3/4? Yeah, 3 3/4. Okay, I'm going to do it on my number line over here to the right because I ran myself out of room. So my number line will look something like this. A pretty little line. All right. So I need to show 5 1/4. And I need to show negative 3 3/4. My points will be closed points because I did say equals to. That's something that by now you just have to stick on a brain cell. You just can't let yourself forget that anymore. I need the numbers that are greater than 5 1/4 or the numbers that are less than negative 3 3/4. And you're saying, well, wait, isn't it greater than or equal to? Yeah, but I've already included the endpoints by coloring in the point. And there you go. That's what your graph looks like. Okay, 2-question video quiz here. Problem number 1, absolute value of 5x plus 3 equals 2. And the second problem is absolute value of 3x minus 5 is less than 15. That's it for the video. Mr. Lawrence signing off. Have a good night, everybody.